Okay, this is Mr. Gillum, and today we're looking at the independent practice, and this is going to be an answer key for the assignment that you've already completed from your instruction book. Please write everything down that's on this video so that you have a good reference in the future. It's on page 68 of your instruction book. The first problem says, what is the value of the expression 3/8 divided by 1 1/2? This would be a classic keep, change, flip method problem. We can really only use the double number line and model well if the first number is bigger than the second number. It's really only effective for that. And in this case, 3/8 is smaller than 1 1/2. So when I notice the mixed number, that's one of the important parts there. I know that 1 1/2 could be modeled like this. And that really is the same as 3/2. Many of you know 2 times 1 plus 1 is 3, so 3/2. So really I'm thinking 3/8 divided by 3/2. And then the keep, change, flip method, because division, multiplication are inverses, we can say keep the 3/8, change the division and multiplication, and invert the second fraction or find the reciprocal of the second fraction. 2/3. And then we can multiply straight across. So I'm going to do that in red marker because that's not really how I would do it. 6 over 24. I know that 6 goes into 6 once and into 24 4 times. So I know that would be 1/4, which is choice D, is which the book got. What I would prefer you to do and to start learning how to do is to look to reduce anything before you multiply. 3 and 3 share 3 in common, go into once, and 2 and 8 share 2 in common. And so now when I multiply straight across, I have no reducing left to do. I go straight to 1/4. To me, even though these numbers aren't impossible to reduce, reducing 3 with itself is much faster than reducing a 6 and a 24. Okay, so I prefer to cross reduce or reduce above and below before I multiply. It keeps the number smaller. It says find the expression that does not answer the question, what fraction of 8 is 2 1/2? So one of these is not the correct answer. That's the one we're trying to identify. If I divide 2 1/2 by 8, it says which one does not answer. What fraction of 8 is 2 1/2? That's like saying I have 2 1/2 out of 8. That is the fraction 2 1/2 of 8. So I know 2 1/2 divided by 8. Yeah, that's fine. 5/2 times 1/8. Ooh, that's a tricky one. Let's think about this. If I have 2 1/2 divided by 8, that's the same as 5/2 divided by 8, or 5/2 divided by 8 over 1, or 5/2 multiplied by 1/8. And that is what B says, so that one's okay. Or we could say, okay, so now 8 divided by 2 1/2, obviously the order is flipped in this one. Order reversed. We'll say that. In that one. And then something times 8 that equals 2 1/2, that is literally how division works. A number times 8 that should equal 2 1/2. So that one's okay as well. Okay. So like when I think without improper fractions, I just think, or mixed numbers, I think, okay, 2 times something equals 6. That's what I think sometimes when I'm dividing, but really that's the same as thinking, what is 6 divided by 2? That's the same number. These numbers are the same. Okay, so choice C would be the incorrect choice. On these problems, a lot of times, if you know that only one doesn't match, you can just solve or simplify each of these and figure out which solution doesn't match, and that's another way that you could solve those as well. Is the area in one dimension of a piece of land are given. From the choices on the left, write the fraction inside each box that represents the second dimension of the land described. All right, so I guess we need a little background information about area for this. And so hopefully you've talked about area with your teacher before. In every one of these problems, as I look through them, I see a rectangular piece of land, the shape of a triangle, and I see a rectangular piece of land. So I know that rectangles, area represents the amount of space inside. That's called area. Each side length is called a dimension. Okay, so like when you're talking about like what lumber yard, it's like 2x4 or 2x8 or whatever. Those are dimensions. And then I know that a lot of times we refer to one side as the length and one side as the width in a rectangle. So I know that the area of a rectangle is the length times the width. Okay, that relationship could also be written. We could also find the width if we take the area divided by the length. Or we could find the length if we take the area divided by the width, because they need to multiply to find the area. So that is a relationship that you needed to be familiar with to solve some of these problems. We'll talk about the triangle when we do the second part here in just a second. This one says that the area of a piece of land is 1/2 of a square mile. So there's a rectangular, and the inside is 1/2. All the space inside is 1/2. Square mile indicates that that's the amount of space inside. One dimension is 7/8 of a mile. We need to find the other dimension. So I know that 7/8 times something must equal 1/2. So I take 1/2 divided by 7/8. I should know what it is that multiplies by 7/8 to get to 1/2. So keep change flip, cross reduce, or multiply straight across. 16 over 14, which is really 8 over 7, or 1 1/7. I would reduce like this, and then I wouldn't have to reduce later. It should not be 16, it should be 8 there. Sorry about that. 4/7. Boo boo. Okay, so 4/7 is what I'm going to say. Let's see if Mr. Gillen was right. Oh, the answer's already on there. 4/7. Good job, Mr. Gillen. We got it right. The area of a piece of, okay, we're going to skip that one for now. The area of a rectangular piece of land, we're going down to this guy right here. It says the area of a rectangular piece of land is 2/3 square mile. So that's how much space is on the inside. One dimension is 1.5 miles. We need to know what the other dimension is. So I know that 1 1/2 times something must equal 2/3. So I need to figure out 2/3 divided by 1 1/2 will tell me what I need to multiply 1 1/2 by to get to 2/3. So when I take, I'm going to run out of space here. When I take 2/3 divided by 1 1/2, I'm really dividing by 3/2. Okay, 2 times 1 is 2, plus 1 is 3, 3/2. And I can do the keep change flip method again. 2/3 times 2/3, multiply straight across, 4/9. And we got that one okay. This is the area of a piece of land. Now we're looking at that middle one here. Now here's where things get tricky. So the area of a piece of land is in the shape of a triangle, is 1/2 square mile. I'm going to draw a triangle, and I'm going to draw a right triangle. This really only works for right triangles. I wish they would have put a right triangle shape of land. Because I'm not sure what dimension it could be for the 4/21. Anyway, it says that the area is 1/12. That's how much space fits inside the triangle, and one of the dimensions, and we're going to put that next to the right angle. We're not going to call this dimension the 4/21. We're going to call this one 4/21, and so I know something 4/21 times something must equal 1/12. To figure out what that is, I can say, okay, well, 1/12 divided by 4/21 should tell me what I need to multiply it by to get back to 1/12. So keep change flip, 1/12 times 21/4. You can multiply straight across to get 21/48. And if I reduce that, I get, if I divide by 7, that's 3. I don't know. If I divide by 3, that would be 7 over looks like 1. Okay, 48 divided by 3, that would be 1 minus 3, 1, 8, 16, 16. Okay, so it looks to me like I have 7/16. Now, that's not what the answer says. It says 7/8. There's a reason for that. If you notice, what we did is we considered the piece of land as a rectangle. But we don't have a rectangle this time, we have a triangle. Now, if there's something I know about triangles, it's that they have exactly half of the amount of space as a rectangle. So when I consider areas length times width, I need to reconsider that because that would be twice as much space as I need. So in this case, what I need to do is I need to multiply that by 2, because when I find the area of a triangle, I'm dividing by 2. So I need to continue on. 14/16 is really 7/8. That is a tough one. So if you got that one, nice job. That's a tough one. I guess I should say one more thing about the area of a triangle. The area of a triangle, just for a triangle, is the base times the height divided by 2. And so that division by 2, because a triangle is exactly half of a quadrilateral, that's why I had to multiply this value by 2, because it was actually half as big as what it should have been. So I hope that makes sense. It's a tough one right there. The next one says write each expression in the correct column to show whether the quotient is less than, greater than, or equal to 1. So this one pretty much speaks for itself. What you need to do is you need to find the quotient of each of these 6 different division problems. And the quotient is the result of a division. So you can see that 3/4 divided by 1/2 is in this column. And I'm going to let you just kind of look at which one goes where. In order to figure out which one goes in each column, one way you could do that is you could just literally do the problem with the keep, change, flip method. It might be a good time to practice your cross reducing. There's 3 halves, or 1 and 1/2. So I know that that would be bigger than 1. 1 and 1/2 is greater than 1, so that's why it's in the greater than 1 column. So I think we are pretty familiar with the keep, change, flip method. These are the answers for each one. If you did not identify them in the right column, I think you need to rework your arithmetic there on those. So to be clear, you did need to actually solve each one of those, but I'm not going to take the time here because it's the same method many times over. It's just really it's a repetition practice for you to do. It says explain the difference between dividing in half and dividing by half using pictures, models, or numbers. Okay, so when I divide in half, so here's what I would do. So if I'm dividing in half, I'm making 2 equal parts. When I'm dividing by half, I am seeing how many 1/2s fit into the whole. There are 8 halves in these holes, so 8. I shouldn't have wrote 8 halves. There are 8 1/2 pieces. This represents 4 divided by 1/2, which is dividing by half. That would represent 8. When I find half of something, I'm finding 1/2 of something, which would be, in this case, 2. So I'm cutting this one in half, dividing in half, and I'm dividing by half over here, dividing by the fraction 1/2. There are 8 1/2s in 4 holes. When I'm dividing in half, I have 2. I just want half of something. Oh, I guess I should show you what the, oh, it's already on there. It says dividing in half means dividing into 2 parts or multiplying by 1/2. Dividing by half means finding how many halves there are in the number. If you divide 4 in half, you get 2. If you divide 4 by 1/2, you get 8. There are 8 halves in 4. Yeah, that's pretty much what I said too. I like it. It says write a story to represent the expression 6 divided by 3/4. Draw a model and use multiplication to show the solution. Explain how the dividend, divisor, and quotient relate to the story. So this is all just possible. I mean, I'm going to have to look through these and just see. This is an example of one way to do it. You can see here that in this expression, we do have a big number divided by a number that's smaller, so it's okay to model on a double number line. And you can see that they made 6 holes here, from the bottom to the top, and divided. See how many 3/4 fit into there. So every time you can see it as well. This 1/4, 2/4, 3/4 hole. 1/4, 2/4, 3/4 hole. Okay, it's all divided in. You can count how many 3/4. 1, 2, 3, 4, 5, 6, 7, 8 through the model. So 6 divided by 3/4 would be 8. You could also use the keep, change, flip method, like so. 24/3, which is also 8, or you could cross reduce 8 and get it there a little quicker. It says a recipe calls for 6 cups of flour. The only measuring cup you have is 3/4 cups. How many times will you have to fill the measuring cup to get 6 cups of flour? So there's an example.